December 12, 1942, Richmond, California. The air hangs heavy with the metallic scent of hot steel. A wall of orange sparks showers the night as thousands of workers swarm the massive hull of a Victory-class cargo ship. Beneath floodlights, cranes swing with mechanical precision. Steel plates clang into place, and the shipyard thrums like a living machine. But behind the noise, there's a silent enemy. Time, 32 days. That's how long it usually takes to build one of these giants. 32 days too long for a war being lost at sea. German U-boats are sinking Allied merchant ships faster than they can be replaced. Supplies to Britain, fuel, grain, ammunition, bleed away in the Atlantic. And then, a single welder raises his hand with an idea that makes the foreman laugh out loud. It sounds absurd, reckless. But within weeks, this ridiculous trick will shatter every shipbuilding record ever set. The world will watch a steel colossus rise from the ground. Not in 32 days, but in 5. The battle for the Atlantic is no longer just on the waves. It begins here, in a California shipyard, under cold floodlights and sparks. This moment is only the spark. To understand why it mattered, we must step back to the world it was born into. In the early months of 1942, the war at sea was a slaughter. The Battle of the Atlantic, the longest continuous military campaign of World War II, had reached its cruelest rhythm. German U-boats roamed the North Atlantic with brutal efficiency, sinking Allied merchant ships at a rate faster than they could be replaced. The Kriegsmarine called it Die glückliche Zeit, the happy time. For the Allies, it was anything but. By spring, entire convoys disappeared beneath the waves. Tankers carrying vital oil to Britain burned in the cold Atlantic. Freighters loaded with food, munitions, and medical supplies vanished into dark water without warning. In a single month, over 600,000 tons of Allied shipping were lost. Britain, already isolated by German occupation of continental Europe, was bleeding. The Atlantic lifeline, the artery keeping Britain alive, was being severed ship by ship. The Allies had the men. They had the factories, but they lacked ships. Each lost freighter meant more rationing, more delays, and less pressure on Nazi Germany. Winston Churchill would later admit that the only thing that truly frightened him during the war was the U-boat peril. Across the Atlantic, Washington faced the scale of the crisis with grim clarity. America had entered the war after Pearl Harbor, and now the arsenal of democracy had to reach beyond weapons. It had to rebuild the very lifelines of global war. Shipbuilding, not battleships or carriers, but the unsung cargo ships, became a strategic priority, as critical as any front line. But shipbuilding was slow. Too slow. Traditional merchant vessels took months to complete. Even with expanded yards and new contracts, it would take years to outbuild the German U-boats at the current pace. In 1941, the United States Maritime Commission began a crash program to mass-produce standardized freighters, the Liberty ships. Simple, boxy, utilitarian, but capable of carrying 10,000 tons of cargo each. They were designed not for elegance, but for quantity. Still, even Liberty ships required time, around 230 days in the beginning. Then with early improvements, 50 days. But by 1942, the Navy and Maritime Commission needed more than improvement. They needed a miracle. That miracle would not come from a grand laboratory or an admiral's office. It would rise from the shipyards, gritty, industrial cathedrals of war. And at the heart of this transformation stood one name that would reshape industrial warfare: Henry J. Kaiser. A man with no formal shipbuilding experience who promised to build freighters faster than anyone in history. To many, it sounded like patriotic fantasy. To Kaiser, it was engineering inevitability. His shipyards in Richmond, California, and along the West Coast became symbols of speed. Thousands of workers, Welders, riveters, crane operators, and many women entering industrial work for the first time, labored in round-the-clock shifts. The docks blazed with light through the night. The tempo was relentless. The goal was simple: turn shipbuilding into something closer to mass production than artisanal craft. But even Kaiser's pace, already astonishing by pre-war standards, wasn't enough. Ships still required weeks to piece together. The welding techniques, though faster than riveting, were locked in rigid sequences that dictated the pace of assembly. And the Atlantic would not wait. Every day lost meant another convoy gone. The pressure wasn't just technical. It was psychological. The Atlantic campaign had become a race against a silent killer below the waves. America's strategy depended on overwhelming that killer with sheer volume. Ships built faster than the U-boats could sink them. Somewhere inside that roaring, fiery world of steel and sparks, one welder would dare to question the sequence itself. To understand why that moment mattered, we must step deeper into the machinery of America's war industry. The United States in 1942 was not just fighting a war overseas, it was building an entire war machine at home. Factories that once made automobiles now stamped out aircraft frames. Rail yards funneled rivers of steel toward ports. Shipyards along both coasts became the beating heart of the logistics effort. And at the center of this massive operation stood a new breed of ship: the Liberty, and later, the Victory ship. Traditional merchant shipbuilding in the interwar years had been slow and meticulous. Shipyards built vessels piece by piece, often on site, with craftsmen riveting steel plates by hand. It was an art as much as it was a trade. Each ship bore the unique touch of the men who assembled it. That was a luxury the Allies could no longer afford. The Liberty ships, introduced in 1941, were designed for mass production. They were simple, standardized, and could be built in multiple yards simultaneously using the same blueprints. Their goal was not to outgun the enemy, but to outbuild them. They could carry 10,000 tons of supplies, trucks, ammunition, tanks, or even troops across the ocean. They were ugly, slow, and utilitarian, but they were vital. Yet even this system had limitations. Early Liberty ships took nearly 200 to 230 days to build. Through optimization, that number fell dramatically, down to around 50 days in many yards by late 1942. But the U-boats were not slowing down. By the time one Liberty ship slid down the ways, dozens more could be sunk. This is where Henry Kaiser changed everything. Unlike traditional shipbuilders, Kaiser approached the shipyard like a factory. He broke down complex construction into modular components. Sections of the ship, the bow, midship, stern, were prefabricated elsewhere and brought together like a gigantic steel puzzle. This was revolutionary. A ship no longer had to be born from the keel upward, slowly. It could be assembled like a product on a line. Kaiser's shipyards operated day and night, using a workforce that reflected the total mobilization of American society. Women welders, Rosie the riveters, joined men on the lines. Migrant workers from the Dust Bowl states filled the barracks near the docks. Entire communities were built around these shipyards, fed by wartime urgency and government contracts. The welding technology itself was also changing the game. Instead of the laborious and time-consuming riveting method, shipyards increasingly used welding, which was faster and required fewer hands. But the welding had to follow a precise sequence. Certain joints needed to be laid before others, or the steel structure could twist and buckle. This sequence, carefully designed and enforced, became the bottleneck. Even the most efficient yard could only accelerate so far before physics itself slowed them down. In other words, speed had a ceiling. Or at least, it seemed to. Every worker in the yard felt the pressure. A welder missing a shift could delay an entire hull. A single misaligned plate could set a project back days. Navy inspectors stalked the yards to ensure no shortcuts threatened seaworthiness. Everything was timed. Everything was controlled. And still, ships rolled out too slowly. Meanwhile, German Admiral Karl Dönitz's wolf packs were intensifying their hunt. In the first half of 1942 alone, U-boats sank over 3 million tons of shipping. The Allies knew they had to produce faster, not just more. In the back rooms of Washington and London, logistics planners calculated how many ships needed to survive each month just to keep Britain fed and supplied. Back in Richmond, the pressure trickled down from boardrooms to boiler rooms. Workers were told they were the front line at home. Posters reminded them that speed means lives. But speed also meant risk. Welding out of sequence could warp the hull, cause structural failure, or lead to catastrophic breakdown at sea. That's why foremen laughed when one welder quietly suggested a way to flip that sequence on its head. It was not a corporate initiative, not a blueprint rewrite from Washington. It was a moment of human audacity. From someone who had spent hours at the hull, seeing not just steel, but patterns others missed. That idea would lead to something unthinkable. A fully built Victory-class ship in just 5 days. Before that moment, however, we need to see the different angles that collided in this story. Human, technological, industrial, and strategic. In the deafening chorus of a wartime shipyard, individuals usually disappear into the machine. Welders, riveters, crane operators, they are the anonymous hands behind history. But sometimes, a single pair of hands alters the rhythm of an entire war. His name rarely appeared in newspapers. He was one of tens of thousands of workers at Kaiser's Richmond shipyards. A welder with long shifts and rough hands who had spent months watching the skeletal steel frames of Liberty and Victory ships rise plate by plate. He noticed something that supervisors overlooked. The sequence of welds was wasting time. Steel plates had to cool before the next step. Workers waited idly between passes. It was accepted as fact, as tradition. But in war, tradition is a luxury. He proposed something simple, almost naive. Reverse and overlap certain weld sequences. Start welding in areas considered secondary first, while primary plates were still cooling elsewhere. This way, instead of waiting, multiple teams could work simultaneously. It defied standard practice. Foremen laughed. That's not how ships are built, they said. But physics didn't care about tradition either. Quietly, this welder and a small team proved it worked. It didn't compromise the structure. It didn't warp the hull. What it did was slash idle time and unlock a new tempo of assembly. In that moment, the invisible hand of one worker set a spark that would burn through every shipyard timeline in America. Henry Kaiser's empire was more than a shipyard. It was a living, breathing industrial organism. Richmond's yards were laid out like giant conveyor belts. Steel plates entered at one end. Victory ships rolled out at the other. Where other yards saw construction, Kaiser saw assembly lines. He borrowed principles from Detroit's automotive industry: speed through repetition, uniformity, and modular construction. Prefabricated sections were built in separate areas and then brought together to form the hull. It was the industrialization of shipbuilding, something the naval establishment had once thought impossible. Every minute in Kaiser's yard was measured. Cranes swung with clockwork precision. Rail lines delivered components just in time. Thousands of workers rotated through overlapping shifts, ensuring that the shipyard never truly slept. But even in this near-perfect rhythm, bottlenecks remained. And most of them centered on welding. Welders were often forced to wait between critical stages. The machine had gears that didn't turn fast enough. The welder's trick, reversing and overlapping sequences, wasn't just clever. It fit perfectly into Kaiser's modular vision. It allowed different modules to advance without waiting on each other. Suddenly, the assembly line wasn't just efficient, it was accelerated. Before the war, shipbuilding meant riveting. Thousands of men with pneumatic hammers fastening red-hot rivets, plate after plate. It was slow, loud, and manpower-heavy. Each joint took time. Each mistake was costly. Welding changed everything. By fusing steel plates directly, shipyards eliminated countless rivets, reduced weight, and required fewer workers for each joint. Welding could be performed faster and more flexibly, but it came with a caveat. Sequence mattered. Weld the wrong section at the wrong time, and the steel would twist as it cooled. Ships could buckle. Structural integrity could fail. That's why welding protocols were rigid. The welder's insight targeted this very rigidity. By identifying neutral weld zones that wouldn't affect structural alignment, he enabled simultaneous operations that once had to be sequential. That was more than a time saver. It was a shift in technological doctrine. This was the kind of innovation wars often produce. Not a new tool, but a new way to use an old tool. And in this case, the tool was fire itself. Far away from Richmond, under the cold gray Atlantic, German U-boats prowled. Admiral Karl Dönitz's wolf packs stalked merchant convoys with lethal precision. Their mission was simple: strangle Britain into submission by sinking the ships that fed its war machine. Every day, a Victory or Liberty ship wasn't at sea meant another hole in the Allied supply line. By 1942, the U-boat fleet was at its most lethal. Hundreds of Allied ships lay at the bottom of the ocean. Supply losses were crippling bomber fuel delivery, food shipments, tank transport. The clock was ticking, and everyone knew it. This relentless external pressure shaped every decision in the shipyards. Posters reminded workers, "The faster you weld, the faster we win." Production wasn't just about pride or wages, it was about survival. U-boats were sinking an average of 20 merchant ships a week. If the Allies couldn't outbuild the wolf packs, they would lose the war long before D-Day. It was this pressure that made the welders' ridiculous idea impossible to ignore. Not because it was perfect, but because the alternative was defeat. But this story wasn't just built on one man's trick or an industrial machine. It was also shaped by leadership, ideals, and the moral weight of a nation at war. Henry J. Kaiser was not a naval architect. He was not a career shipbuilder. He was, in many ways, an outsider. Before the war, he made his fortune in construction: dams, roads, bridges. But when Washington asked for ships, Kaiser didn't see tradition. He saw a problem to be solved, and he was willing to challenge every orthodoxy to solve it. At the start of the war, established shipbuilders scoffed at his claims. A ship in weeks? Impossible. Welding over riveting? Risky. Prefabrication? Unthinkable at scale. Yet Kaiser built his own system from scratch. Vast yards in Richmond, Vancouver, and beyond. He hired tens of thousands of workers, many with no shipbuilding experience, and trained them quickly. His mantra was simple: speed and volume win wars. When that unknown welder proposed his trick, reversing weld sequences, Kaiser didn't dismiss it outright. He had built a culture where innovation could rise from the floor, not just from the top. Foremen tested it. Engineers measured results. Within days, the sequence became a formalized method. Kaiser's genius wasn't just in steel, it was in listening. And when the world watched the SS Robert E. Peary slide into the water after just 5 days of assembly, Kaiser didn't credit a single man. He credited the system. But inside the yard, everyone knew how it had started, with a welder's spark and a leader willing to let it burn. This was more than shipbuilding. It was national resolve forged in steel. In 1942, every American worker knew that their hands were part of something larger. They read the headlines of convoys lost to the U-boats. They knew that without cargo ships, soldiers would starve on distant shores. Every weld was a lifeline. Every ship was a weapon. For many of the men and women at Richmond, this wasn't just a job. It was a mission. Women who had never held a torch before learned to weld in weeks. Migrant workers who had fled the Dust Bowl found purpose in those yards. Union men, Engineers, African Americans from the South, young apprentices, they worked shoulder to shoulder on the same steel hulls. Under floodlights and fog, they became the industrial front line. And behind every record broken, there was a shared understanding. Speed saved lives. If a ship could be finished 10 days earlier, it meant convoys sailed stronger, supply lines held firmer, and fewer men died in the cold black Atlantic. It wasn't romantic, it was brutally practical. But it gave meaning to every spark. This moral force was the fuel that powered Kaiser's empire and amplified the Welder's trick into a national weapon of production. And then came the moment when theory turned into steel, when an idea met the clock, and the world watched a ship rise in 5 days. December 8th, 1942. Richmond Shipyard, Number 2. The air was sharp and cold, but the docks burned with motion. Floodlights carved hard white lines across the hull of a Victory-class ship, the SS Robert E. Peary. She wasn't just another freighter. She was the gamble. All across the country, newspapers had caught wind of Kaiser's bold claim to build a fully operational cargo ship in a fraction of the normal time. The Navy had sent observers. Maritime Commission officials crowded into makeshift viewing stands. Foremen had been briefed again and again. Welders knew this wasn't another shift. It was the shift that would test the impossible. At dawn, the keel blocks were already in place. Prefabricated sections, some weighing dozens of tons, waited like enormous puzzle pieces along the ways. Cranes swung overhead in careful rhythm. The teams moved in overlapping waves. Where once welders waited for plates to cool before advancing, they now leapt ahead, working in parallel across neutral joints and secondary seams. The welder's ridiculous trick was no longer a rumor. It was the backbone of the operation. Hours blurred together, steam curled from hot welds as sparks cascaded into the winter air. Instead of single crews waiting on a bottleneck, entire segments were racing forward simultaneously. Stern assemblies rose while the midship sections were still being set. The bow came together while internal bulkheads were welded below. For the first time in modern shipbuilding, the sequence didn't control the yard. The yard controlled the sequence. Day 2. The skeleton had taken form. Pipes, deck plates, and fittings arrived in synchronized convoys. Kaiser's logistical choreography was working with brutal precision. Observers watched in disbelief as hull sections that normally required days of alignment were joined in hours. Supervisors kept time down to the minute. Day 3. The hull was complete. The deck houses rose. Welding continued around the clock. Night shifts and day shifts bleeding into one seamless engine of production. The rhythm was relentless. There were no pauses, no dead hours, no wasted seconds. In a war where every convoy counted, this was speed weaponized. Day 4. Riggers and electricians swarmed the ship. Boilers were installed. Wiring snaked through steel corridors. Pipe fitters worked shoulder to shoulder with welders, everything happening in layers, not lines. Reporters stood outside the fence, catching glimpses of sparks and silhouettes. The story had spread far beyond Richmond. Rival shipyards didn't believe it could be done. Day 5. The Robert E. Peary slid into the water. Observers clocked the build at 4 days, 15 hours, and 29 minutes from the laying of the keel to launch. The fastest construction of a merchant ship in history. The crowd roared. Sirens howled across the yard. Workers threw their helmets in the air, not because they had built a ship, but because they had shattered time. The impossible had fallen not through invention, but through audacity, logistics, and a welder's unorthodox sequence. Naval officers who once dismissed Kaiser's speed as showmanship now stood speechless. Even the Maritime Commission, accustomed to miracle stories, called it a new frontier in industrial warfare. And this was only the beginning. Because in the days that followed, the shockwave of the SS Robert E. Peary would ripple far beyond Richmond. The moment the Robert E. Peary touched the water, the story detonated like a flare. Newspapers carried the headline across the United States. Ship built in 5 days. Kaiser breaks record. Welders make history on West Coast. For the American public, weary from casualty lists, rationing, and grim news from the Atlantic, this was more than an engineering feat. It was a symbol of hope. The impossible had been done not by admirals or inventors, but by welders, pipe fitters, and crane operators. Ordinary people had built a ship faster than the enemy could sink one, and they had done it in 5 days. The U.S. Navy, which had long balanced caution with ambition, took note. Behind closed doors, Maritime Commission officials studied every hour of the build, dissecting the schedule like a battle plan. How had so many stages overlapped without chaos? How had the hull held firm despite the break with convention? The answer wasn't a single trick. It was a system, a sequence designed for speed, flexibility, and absolute coordination. Kaiser's team documented every step. Engineers codified the welding sequence reversal into formal production protocols to be distributed to other yards. Within weeks, yards from Portland to New Orleans were adopting elements of the Richmond method. The idea had escaped the confines of one welder's mind and become a national blueprint. But this achievement didn't go unnoticed across the ocean either. German naval intelligence intercepted press reports and internal U.S. communiques. In Berlin, Admiral Karl Donitz's staff analyzed the numbers. If the Allies could truly build ships this fast, the U-boat strategy was facing a ticking clock. It wasn't enough to sink ships anymore. They would have to sink them faster than the Americans could build them. And suddenly, that math no longer favored Germany. Back in the U.S., the launch of the Robert E. Peary became a public morale rallying point. Photographs of smiling welders, sparks flying against the night, appeared in newspapers and propaganda posters. They weren't anonymous anymore. They were the face of the arsenal of democracy. Families on the home front clipped articles, workers in other industries taped them to factory walls. This was proof that ingenuity could bend reality. In shipyards, something subtle but powerful changed. Before the Peary, welders followed the blueprint like scripture. After the Peary, they began to question it. Supervisors encouraged field innovations. The culture shifted from follow the plan to make it faster. This was not reckless. It was engineered boldness. The Robert E. Peary herself went on to serve in the war, crossing the Atlantic with supplies, part of the vast convoys that kept Britain alive and prepared for the invasions to come. But her greatest legacy wasn't the steel hull that floated that December morning. It was the shockwave of belief, the knowledge that shipbuilding speed was no longer measured in weeks, but in days. For Germany, it marked a quiet but decisive moment. The U-boat war had met its match not at sea, but in American shipyards. For America, it marked a turning point. Industrial speed had become a strategic weapon. But the real weight of this event wasn't just felt on launch day. It was in the months that followed, as shipyards transformed, production soared, and the tide of the war began to turn. By early 1943, the Robert E. Peary was no longer just a ship. It was a standard. Shipyards across the United States studied the Richmond method like a combat manual. Welding foremen, engineers, and production planners pored over diagrams of reversed sequences, staggered weld zones, and overlapping stages. The innovation that had been dismissed as reckless now became the blueprint for speed. Henry Kaiser's yards led the charge. Prefabrication, once considered experimental, became the backbone of modern American shipbuilding. The idea of working in layers, not lines, spread rapidly. Instead of crews waiting for their turn in a strict chain, they were assigned to simultaneous zones of action. It wasn't just a faster method. It was a new language of industrial warfare. production numbers began to climb at an astonishing rate. In 1941, the United States had produced just over 200 merchant ships. By the end of 1943, over 2,100 ships were launched. Liberty and Victory ships slid down ways at a pace the world had never seen. Some were built in 20 days, some in 15. A few, like the Peary, pushed the limits below a week. This surge wasn't magic. It was systemic momentum. Kaiser's innovations, combined with national coordination, massive resource allocation, and the will of a workforce that understood what was at stake, created an output Germany could not match. The U-boat fleets were still deadly, but they were now drowning in the sheer volume of steel the U.S. was sending to sea. The Richmond yards became legendary. Photographers captured their night glow, an endless horizon of sparks, cranes, and hulls. American war planners began to factor speed itself as a weapon, adjusting convoy tactics, knowing that losses could be rapidly replaced. What had once been a desperate race against time was slowly tipping toward overwhelming force. For the workers, the effect was equally profound. A welder's idea had shown that innovation didn't only belong to engineers or officers. It belonged to anyone who understood the rhythm of the work. In the long rows of hulls, men and women saw proof that their hands could change the war's tempo. And in Berlin, Admiral Dönitz received shipping reports with growing unease. The numbers told a simple, devastating story. Even if the U-boats doubled their kills, America could build more. But the ripple didn't stop at America's shores. It reshaped logistics, strategy, and the scale of Allied power across the globe. In the months after the Robert E. Peary's 5-day miracle, the war at sea began to shift, quietly, steadily, and decisively. The Atlantic, once a graveyard of Allied ships, was slowly turning into a supply highway, not because the U-boats had vanished, but because they could no longer keep up. By mid-1943, American shipyards were launching merchant ships at a rate of 2 per day. The Liberty and Victory ships, built faster than ever, filled the convoys that crossed the North Atlantic in endless columns. In 1942, Allied shipping losses had outpaced production. By the end of 1943, production had outpaced losses by a factor of more than 2. This was a turning point that didn't explode in a single battle. It was fought in sparks, cranes, and welding arcs, and it reshaped the strategic map of the war. Britain, once on the brink of starvation and supply collapse, now saw its stockpiles stabilize. Food, oil, trucks, tanks, and aircraft flowed across the ocean in a relentless surge. Convoy operations were restructured. Longer, heavier, better protected. With replacement ships readily available, convoy planners could take greater risks, reroute, and tighten the noose on Axis supply lines. For Germany, the numbers were merciless. The Kriegsmarine had relied on attrition, but when a sunken freighter could be replaced faster than a U-boat could sink its next target, the strategy cracked. Admiral Dönitz had once believed that 300 operational U-boats could strangle Britain. By late 1943, despite fielding more than 400, they couldn't keep up with the steel tide. Meanwhile, the Victory ships, more modern successors to the Liberty class, entered production. Faster, more durable, and designed for post-war service, they embodied everything the Peary moment represented. A fusion of innovation and scale. Their impact went far beyond the Atlantic. These ships fueled the North African campaigns, carried Sherman tanks to Normandy, delivered fuel to the Pacific Front, and built the logistical bridge that made global operations possible. They were the silent backbone of the Allied advance. Axis powers could not replicate this scale. German shipyards, hampered by limited resources, Allied bombing, and a lack of industrial standardization, were producing a fraction of what the U.S. launched monthly. What America had achieved in one shipyard had reshaped the balance of global production. And at the heart of this industrial avalanche stood an idea. born from the floor of a shipyard. A reversed welding sequence, simple, practical, devastatingly effective. By the war's end, more than 2,700 Liberty ships and over 500 Victory ships had been built. They carried men, machines, and hope across oceans. Many would outlast the war, becoming workhorses of the post-war world. But beyond tonnage and numbers, there was something quieter. The enduring meaning of what happened at Richmond. In war, history often remembers the generals, the admirals, the grand strategies. But sometimes, the tide turns in the quiet moment when one person dares to see differently. The Robert E. Peary was more than steel plates and weld lines. It was proof that the front line isn't always drawn in the mud of a battlefield. Sometimes, it's traced in chalk on a shipyard floor. A single welder, standing under cold floodlights, looked at a rigid system and found space to move faster. What began as a ridiculous trick became an industrial weapon that helped tilt a global war. Henry Kaiser's Empire of Steel amplified that spark. America's workforce, ordinary men and women who had never worn a uniform, carried it forward. Together, they transformed shipbuilding from craft to choreography, turning days into hours and hesitation into momentum. The U-boats could sink ships. They could not sink time. The legacy of that moment reaches beyond the war. The modular construction, prefabrication, and overlapping process pioneered in those shipyards became the foundation for modern manufacturing, from civilian shipbuilding to aerospace. Decades later, engineers would still study how a single shift in method unlocked an empire of speed. But perhaps the most powerful legacy is human. It reminds us that innovation is not born in boardrooms alone. It rises from welders, riveters, machinists, from people who work close enough to the problem to touch it. In December 1942, one such spark helped reshape the course of a world at war. The Atlantic Campaign did not end overnight, but after Richmond, it would never again be the same fight. Under the glare of those floodlights, time itself had been forced to surrender. And from that surrender, a fleet was born. History is built not only by those who fight wars, but by those who build the tools to win them. If you want more untold stories like this, stories where a single spark changes the world, subscribe, join our growing history community, and help keep these moments alive.